Now, let's move on to the final part of Chapter 2, Class and Object. First, let me introduce object-oriented programming. Object-oriented programming is a programming paradigm that organizes software design around objects instead of functions and logic. We need object-oriented programming because as our program grows larger, objects make the code more organized and manageable. We have just learned functional programming, and functions also help organize our code. But with only functions, it is not enough. That's why we need object-oriented programming. Object-oriented programming provides some important features that functional programming doesn't have. And these features allow us to model real-world scenario much simpler. I will introduce these features soon. Now, let's take a look at the comparison between object-oriented programming and functional programming. We can see that object-oriented programming is much more readable and understandable. Here we create an employee object. We can easily understand that employee has name and age. In functional programming, it's relatively hard to see the relationship between name and age. Before I introduce the features of object-oriented programming, we need to know what class and object are. An object is a collection of data and methods that act on those data. For example, we can have a variable A and a function that returns A. In object-oriented programming, we used to call those variables data. And we used to call those functions methods. Now, let's see what class is. A class is a blueprint for an object. We can think of class as a blueprint for a car. It contains all the details about the engine, driving wheel, doors, etc. Based on these descriptions, we build the car, and the car is the object. As many cars can be made from a car's blueprint, we can create many objects from a class. An object is also called an instance of a class. And the process of creating this object is called instantiation. Since Python is an object-oriented programming language, almost everything in Python is an object. Python programmers organize software design around objects rather than functions and logic. And Python classes provide all the standard features of object-oriented programming. We will mainly introduce the following features of class and object: encapsulation, inheritance, abstraction, and polymorphism. First, let's take a look at encapsulation. Encapsulation is one of the fundamental features in object-oriented programming. The idea is combining data and methods that act on those data within an object. Encapsulation can be used to hide the value of data inside an object, preventing unauthorized parties from direct accessing them. For example, we can consider the object as a car. Okay? The car. And there are data such as windows and maybe doors. these are data that we can see. But there are also data that we should not see, which is the engine inside. And encapsulation prevents us from seeing these data. We cannot see the engine. Now, let's see inheritance. Inheritance allows us to define a class that inherits all the methods and data from another class. The child class is the class that inherits from another class. And the parent class is the class being inherited from. Inheritance is a powerful feature in object-oriented programming. It allows us to define a new class with little or no modification to an existing class. This makes it easier to maintain our code. It also increases the reusability of our code. Next, let's see abstraction. So we have blueprints for objects, which are classes. And we can also have blueprints for classes as well. We call these kind of blueprints abstract classes. So an abstract class is like a blueprint for other classes. A class which contains one or more abstract methods is called an abstract class. An abstract method is a method without any content. When an abstract class is inherited by a child class, the child class must provide implementation for all the abstract methods in the abstract class. Say in the draft of a car blueprint, let's say we want to make a door. We also want to have some windows and an engine. This is the abstract class, the blueprint of the car blueprint. And in our car blueprint, we provide detailed instructions on how the doors are designed. Say we can put it over here, 2 doors, and windows over here, and maybe engine is over here. So we can create a set of methods that must be created. These are methods that must be created within any child classes built from the abstract class. Finally, let's take a look at polymorphism. Polymorphism is the ability of an object to have many forms. Say we have an object representing a car. Now, a car is a car, but it is also a vehicle and a machine. In Python, we can have polymorphic functions. We can also use polymorphism with classes and inheritance. I will explain the details later in the exercise. Now, let's open Jupyter Notebook and take a look at the code. Okay, this is the end of chapter 2. Before we end this lecture, let's have a brief review over what we have learned. We have learned the syntax, data types, and control flow of Python. We also learned how to use functions and understand the concept of object-oriented programming. In the next chapter, I will introduce some advanced features in Python. If you want to know more about our course, you can visit our online learning website. You can also find technical support on Huawei Knowledge Base. Thank you for watching. Hope you enjoyed the lecture. See you.